Welcome to the third lecture video for the fifth class period time in the set of instructional videos. We'll continue going through our naming handout, and hopefully by the end of this handout we'll have a pretty good idea about how to name organic molecules, at least hydrocarbons that are branched, and some that contain groups. Alkanes can be named as groups or appendages on other molecules. When this occurs, the ANE ending becomes YL. So for example, here's a generic methyl group, an H3C group. And here it is in an alcohol, that's methyl alcohol, otherwise known as methanol. There is an ethyl group in terms of a bond line drawing. When Y is bromine, for example, you have ethyl bromide. Here is an N-propyl group. So N-propyl means that we are a linear 3-carbon group, and our substituent is coming off of either of the end carbons. So for example, when Y is a thiol, an SH group, you could call it N-propyl mercaptan or 1-propane thiol. What about when the Y group is bonded to the secondary carbon? Well, the informal name for that is an isopropyl group. The IUPAC name for that particular group is a 1-methyl ethyl group, and we'll get to that in our systematic naming of hydrocarbons. But it's good to be familiar not only with the IUPAC naming system, but also some of these more common names that you encounter frequently. So for example, when our Y group is a hydroxyl group, an OH, we have isopropyl alcohol. Something in short supply when this pandemic started. Notice that there are 2 different isomers for the propyl group. Similarly, there are different isomers for butyl groups, the abbreviations for which you should be familiar. So our N-butyl group, again, has our substituent being bonded to one of the carbons at either termini. We have something called an isobutyl group, where we have literally, it's a 2-methyl propyl group in IUPAC naming, but we call it isobutyl because it would be the same if you bonded the Y to any of the primary carbons in that isobutane. We have a secondary butyl group, or sec-butyl, sometimes abbreviated S-butyl or sec-butyl. And we have a tertiary butyl group, where the Y group is bonded to the tertiary carbon. Just as in the secondary butyl group, the Y group was bonded to a secondary carbon. So in terms of an example here, we have tert-butyl chloride. Of course, our IUPAC naming system would call it 2-chloro-2-methylpropane, but like I said, we'll get to that shortly. There are several isomers for pentyl groups. One with which you should be familiar is the neopentyl group. Here's an example of a Y group bonded to a neopentyl grouping. So there is 1-bromo-2,2-dimethylpropane, or neopentyl bromide in the more common language. So, continuing forward, sometimes we use R to indicate an alkyl group. This is a common habit for organic chemists. So here we have an R bonded to a bromine. So R is taken as an alkyl group, and it could be any alkyl group you could specify. Here we have 2 R groups bonded to the same oxygen. When things are abbreviated like that, the R groups are taken to be the same, whatever they are defined as. You could specify different alkyl groups by having an R and an R prime or an R double prime, etc. So, systematically naming branched alkanes. Finally, we get to the rules, and there are several. So, you'll have to just bear with me until we get through the entire set of rules. Rule 1, find the longest chain in a molecule and name it. So, for example, here we have 3-methylhexane. We'll tell you how to name the branches on it. Here we have 4-ethylheptane. Here we have 3-ethyl 6-methyloctane. So the longest chain in this molecule must have been a 6-membered chain, so a hexane. If I start counting from this end, 1, 2, 3, 4, 4 is less than our longest chain, right? Or if I counted 1, 2, 3, 4, 5, 5 is still less than our longest chain. Our longest chain runs 1, 2, 3, 4, 5, 6 carbons. So that's how it turned out to be a hexane. Similarly, the longest chain in this molecule is a heptane, 7 carbons. The longest chain in this molecule is an octane, 8 carbons. Caveat number 1, if the molecule has 2 or more chains of equal length, then the chain with the largest number of substituents, that is groups, is the base stem chain. So, for example, here we have a heptane, and this particular numbering gives 4 groups. If we had numbered our longest chain in this manner, if we had taken this as our base stem heptane, how many groups would be on it? 1, 2, and this whole thing is another group. It happens to be branched, but it only counts as one group. So we prefer 4 groups versus 3 groups. Rule 2, name all the groups attached to the longest chain as alkyl substituents, that is methyl, ethyl, propyl, etc. If the group is branched, you repeat rules 1 and 2. So for example, this molecule is 2,4-dimethyl-3,1-methylethyl-pentane in the IUPAC system of naming, which we will be asked to use, not necessarily incorporating common names. However, you may see other texts or areas where you're reading organic chemistry that abbreviate the 1-methyl ethyl group as an isopropyl group. So you have to be aware of those common names as you go through your materials. So I think we'll quit at this point with this first rule and the second rule that refer back to each other when naming branch substituents, and we will continue on in the next lecture video to go over the remaining rule.